Today we're going to multiply a fraction or a mixed number by a whole number. So our first one here is 4 times 1/8. Now down below here I have a model. This model is not drawn to scale. It's not a perfect model. If this were perfect, each of these pieces would be all the exact same equal size because we're looking at 8 equal pieces. However, for our reasoning here, this will work for us. And so here we have 1, 2, 3, 4, 5, 6, 7, 8. So one of these spots here would be 1/8. So I'm going to mark it as 1/8. So there's 1/8. Now I want 4 times 1/8. So I'm going to mark 4 total. 1, 2, 3, 4. Now as you can see, I have all 4 of them marked. So my answer for 4 times 1/8 is going to be 4/8, which by looking at our model here, we can also see that that is actually 1/2 of our model. So we can actually say that 4/8 or 1/2 would be our answer. On our next slide here, we have 4 times 2/4. In this case, too, I also have a model once again drawn out here. Once again, not completely perfect as I'd like it, but it'll work for us. And we have our 4 times 2/4. Right here we have our 2/4, 2 marked off out of 4 sections. And we're going to make it so we have 4 of those. So we're just going to mark off another 1, 2, 1, 2, 1, 2. So now as you can see, we have 2/4 here, plus 2/4 here, plus 2/4 here, plus 2/4 here. How many fourths is that going to give us? Well, 1, 2, 3, 4, 5, 6, 7, 8. It gives us 8/4. So we can come over here and we can go 8/4. Now our 8/4 here can actually be broken down or simplified into 2 wholes because we have our 2/4 here, which could be used here to fill up one of these ones here. So I'm going to take blue X's here and I'm going to put a blue X for each one I'm stealing. And we're going to put one there, one there. Once again here. Put one there, and one there. So in simplifying this down, it actually gives us 2 wholes rather than what we had. So we're going to take this and we're going to say equals 2. So 4 times 2/4 equals 8/4 or 2. On our next slide here, we're going to multiply using repeated addition. Now, repeated addition is the exact same thing as multiplication. 4 times 1/2 could be written as, using repeated addition, as 1/2 plus 1/2 plus 1/2 plus 1/2. Notice we have 1/2 1, 2, 3, 4 times. We add that up, and we know as when we add a addition or add a fraction, our denominator stays the same, and we're only adding our numerators. So with that, we are going to get an answer of 4/2. Now our full halves can then be also be equal to 2 halves equal a whole, so could also be equal to 2 because 1/2 plus 1/2 equals 1 and 1/2 plus 1/2 would equal 1, which would give us our answer of 2. On this next one, we're going to multiply using the distributive property. As you can see here, we have our 3 times 2 and 1/4. So we're multiplying 3 times 2 and 3 times 1/4. We're going to write this out. First of all, we're going to write it out as 3 and 2/4. So we're going to go 3 times 2. We're going to separate this, plus 3 times 1/4. This will then allow us to then multiply this correctly. So we know that 3 times 2 is 6, and we're going to be adding that to our 3 times 1/4. Now when we multiply a fraction by a whole number, it is like placing a 1 below our whole number, and then we multiply straight across. So our numerator then becomes the 3, and our denominator becomes a 1. So we take our 3 times 1, which is going to give us, it's not writing, 3, and our 1 times 4, which is going to give us our 4. Now we have our 6 plus our 3/4 is going to give us 6 and 3/4 as our answer. So this is multiplying a whole number by a mixed number, and our answer here is going to be 6 and 3/4. On our note here, we're going to do the same type of thing, only this time I'm going to kind of model it out a little bit. So as you can see, I have drawn a whole bunch of models of our 3's. Okay, these are 3's. The reason I have 3 in each is because our denominator over here is 3. Okay, so that means our whole has to be 3. So every time we have a whole number, that's going to be 3 3's would be our whole number. So in this case, we're going to have our 2 times 3 and 2/3. Okay, so once again, I'm going to separate it as 2 times 3. That's our whole numbers, right? So 3 wholes are going to be 1, 2, there's a whole, there's a second whole, there's 3 wholes, so 3 wholes, but I want 2 times that, so I need 2 of each of those, so there's our 2 times 3 wholes. If you count them now, we have 1 whole, 2, 3, 4, 5, and 6. 2 times 3 is 6. So here's our 6 whole numbers here. So that's going to equal our 6 whole numbers. And then over here we have our 2 times 2/3, which we're going to add over here. And by adding those two together, we'll come up with our answer. So we have our 2 times 2/3. So over here, we're only going to have 2/3 colored in. And then I need another 2/3. So I'm going to do that. I can do that by doing 2/3 right there. However, so we get our answer of 4/3, right? 1, 2, 3, 4. So that gives us 4/3. But 4/3 can then be reduced, and we can reduce that by simply taking one of these x's here, and we'll cross that off, and we'll put it up here. That then gives us 1/3, or 3/3, so another 1. So this is going to then equal a 1 and 1/3. Now we're not quite done yet. We have our 1 and 1/3 over here, and we have our 6 over here. So we need to add those together because we're supposed to add this number here to this number here. So we're going to take our 6. I'm actually going to erase what I had written. Oh, well, let's see. Let me go ahead and erase our... Oh, that's not going to work for me. Okay, well, fine. Okay, so we're going to take our 6 and we're going to add our 1 and 1/3. And we know that 6 plus 1 is 7, and then our 1/3. So our answer is going to be not 6, but 7 and 1/3. And that is how we could use a model to simulate using our distributive property. This last one here, we're going to use repeated addition. Okay, so on this one here, we're going to take our 3 and 2/5, and we're going to multiply it by 3. So we're going to take our 3 and 2/5 using repeated addition. So 3 and 2/5 plus 3 and 2/5 plus 3 and 2/5. Now notice we have 3, 1, 2, 3, and the reason we do that is because we're multiplying by 3. Now we can add these up. Okay, we're going to start by adding our whole numbers. 1, 2, and 3. So we have 3 plus 3, which is 6, plus 3, which is going to be 9. So we're going to take our 9, and we're going to add that to our 5ths. So let's add up our 5ths now. Okay, so we're going to have our 2 plus 2 is 4, plus 2 is 6. So we're going to add our 6/5. Now 6/5 is more than one whole number. 6/5, 5/5 would be one whole. So we're going to simplify our 6/5 before we add these two together. So we're going to say that 6/5 is equal to 6/5. I'm going to put the parenthesis there just so that I'm separating those two things. I'm not adding the 6/5 and saying that's equal to that. I'm simply saying that 6/5 is equal to, well, how many times does 5 go into 6? 5 goes into 6 one time. So we have our 5 here. Our denominator stays the same. 5 times 1 is 5, plus 1 would give us 6. So up here as our numerator, we're going to put a 1. Okay, so that is equal to that, which means our answer then would be 9 plus 1 and 1/5, which is going to equal 9 plus 1 is going to be 10 plus our 1/5. So our answer would be 10 and 1/5. And that is basically how we use various methods, models, and repeated addition, and just multiplication to solve multiplication when a fraction is being multiplied by a whole number, or when a mixed number is multiplied by a whole number.